Hello Python programmers, this is AK. In this video we are going to see about one of the important pre-processing techniques that is called anomaly detection. Anomaly detection is a kind of identifying the rare or suspicious data that present in the original dataset. This is a simple technique in the unsupervised machine learning that is often used for data cleaning process. I will try to explain this concept simply with this picture. So look at this picture. It has some group of fishes. This picture has two variants of fishes. The blue one is the good fish and the red one is the bad fish. By using the differentiation of colors, we can easily detect the anomalies that present in the example image. But when you take the real world data set, which contains a large amount of data that might be present, it is a challenging one to find the anomalies that is present in the data set. For identifying the anomalies, we need to create a program which will detect the anomalies that are present in the data set. Detecting the anomalies is very different for different data sets. If you have less noise in the data set, then you can find the anomalies easily. But if you have high noise, it is a very hard process for detecting the anomalies. In this video, I am going to explain with the cricket scores dataset. I just modified the dataset for this video. This will give you the clear-cut explanations of anomalies detection concept. So watch this video fully to understand the entire concept. Here I imported the required libraries for this problem. Let me give the library explanations. NumPy is for performing the array operations. Pandas is for reading the CSV files and creating data frames. Finally, from the sklearn library, we imported the isolation forest module. That is very important for this problem. So the isolation forest is used to create a tree-like structure based on the data points we have. It builds the tree-like structure based on the closest relationship between the root value and the child value. This module will form the trees according to their closest relation. In the isolation forest, you can decide how many tree values we need to form. Forming a tree is an iterative process in this library. If you want to perform 50 iterations, then you will get some kind of accuracy. Accuracy is based on the data you have. Okay. Suppose if you have less features of data, then the less amount of tree formation is enough to process the data. And if you have large features of data, then you need to form nearly 100 trees or more than 100 trees is enough to process the data. Here I read the dataset of mine. It's a cricket score dataset which was built by me. Now look at my data values here. There are 20 overs are present in the dataset, and in the scores column contain the data of scores which was scored in each overs. So before we find the anomalies that present in the dataset, I want to make some assumptions. In a cricket match, anything can happen in particular overs. We can assume only 36 runs or less than 36 runs are possible runs to score in a single over. And I made the dataset like that. So look at my dataset, you can simply find the anomalies by saying it. In the over of 7, 11, 14, 16 contain some values which are not possible to score in a single over. These are the anomalies that are present in my dataset. And it is only for explaining purposes, but in the real time you need to solve a big problem with a more complex dataset. So next step, you need to create an isolation forest model, create a variable model and create an object isolation forest. In this object, you need to pass these 4 parameters. They are very important for tuning the model performances. Let's see its explanations. N estimator indicates how many iterative trees you need to form from these data points. Suppose you can take the power play overruns. When you give the N estimator value as 50, it will form 50 trees by using only the power play runs. I will post a decision tree algorithm video on next. You can easily understand those concepts and then you can easily relate that with this parameter. Next one is the maximum samples. Maximum samples is a kind of an allocation tool that is used for how many data samples will this algorithm take from the training dataset. Here I gave the value as auto. That means I just gave a permission to this algorithm so it can take any number of samples from the dataset. The third one is the contamination. Contamination means the percentage of randomness that may be present in our dataset. With the help of this parameter, you can easily find out the anomalies in your dataset. And the final one is the maximum features. It means in some dataset, there will be a lot of features may be present. This parameter will allow you to select how many features you need to include while training the algorithm. Here I gave the value as 1.0. It means it draws a single feature from the dataset and using that feature, it will start to train the data with this algorithm. Okay, these are the important parameters you need to know in the isolation forest algorithm. I think I explained all the things correctly, and if you have any doubts about this, then comment down your thoughts. Okay, Next step, we are going to create two columns that are anomaly scores and the anomaly. For checking the anomaly score for each data point, you need to type model.decisionFunction method and pass the scores column in this method. And next one is, if you want to predict the anomaly that present in your cricket data set, type model.predict and pass the scores column in it. So that's all. Let's check how it predicted the anomalies in our data set. Now look at my data frame. So our model performs well and it predicted the data with some numerical values. In the anomaly column contains the data of 1 and -1. 1 means our data is good data and -1 means it's a bad data or an outlier data. This is a proper way of checking the anomalies by using the isolation forest algorithm. There are so many ways to check the anomaly data. If I get enough time, I will definitely make a videos by using another approaches. So that's all about this video. If you like this video, give a like and subscribe and share for more interesting scripts in Python, and comment down your thoughts about this video. Thanks for watching and thank you. See you on next video.